All right, welcome. In this chapter, we're going to explore what it really means to implement an effective testing strategy for modern software. We're going to look at how the best teams are shifting gears, moving way beyond the old idea of just finding bugs, and instead adopting a whole philosophy of building quality right into their software from the very beginning.
For the longest time, software testing was kind of seen as this final, stressful gatekeeper before release. It was this separate phase, almost an afterthought, right? Its whole job was to hunt down bugs that were already in the system. But the modern view, it's a total fundamental shift. It treats testing not as a phase at all, but as a continuous activity that's woven into the entire development lifecycle. So the goal isn't just to find defects anymore, it's to stop them from ever happening in the first place.
So, let's really dig into this crucial shift in mindset. We're talking about moving away from that old model of quality control being some final inspection, and moving towards a culture where quality is a shared responsibility, something the entire team owns, at every single step of the process.
And what's really fascinating is that this whole idea of building quality in, it's not new at all. This quote here comes from W. Edwards Deming, who was this absolute visionary in quality management. His work totally revolutionized manufacturing way back in the mid-20th century. And his core principle is just timeless. You can't inspect quality into a product, you have to build it in from the very start. And for us in the world of software, that means one thing: integrating testing deeply into the development process itself.
So, what does this actually look like in practice? Well, the dream state for a modern software project is a suite of automated tests that does way more than just check for errors. It actually describes, in a way the computer can understand and verify, exactly how the system is supposed to behave. We call this an executable specification. Just think of it like living documentation. It's a blueprint that is always up to date because it's run automatically every single time a developer makes a change. That means you're getting constant, reliable feedback.
Okay, but let's be real for a second. Achieving this ideal state can feel, a little daunting, right? There are just so many different kinds of tests out there, and each one has its own purpose. To make sense of it all and navigate this landscape, we're going to need a map. And in this next section, we're going to introduce a really powerful tool that gives us exactly that.
Think about it. You've probably heard this dizzying array of terms: unit tests, integration tests, acceptance tests, performance tests, security tests. The list just goes on and on. So how do they all fit together? And how in the world do you decide which ones to use and when? Without some kind of clear framework, it's super easy to feel completely overwhelmed. And this is where a model developed by a guy named Brian Merrick called the Testing Quadrant becomes so valuable. It's this really elegant framework that's going to act as our map. It organizes the entire world of testing along two simple axes. Okay, so the horizontal axis, that one separates tests that are technology-facing, stuff about the internal workings for the dev team, from tests that are business-facing, which are all about functionality that non-technical folks can understand. Then you have the vertical axis. This one separates tests that support the programming process from those that critique the project as a whole. It's a simple idea, but it's incredibly powerful. All right, so now let's take a tour of this map. We're going to navigate through each of the four quadrants to really understand the purpose and the value of the tests that live in each area. So, let's start our tour in Quadrant 1. That's the top right. Now remember, these tests are both business-facing and they support programming. This is the home of automated acceptance tests. Their whole job is to verify that the software meets the functional requirements that the business cares about. Simple stuff like, does the Add to Cart button actually add an item to the shopping cart? In a nutshell, these tests answer one crucial question: are we building the product correctly? Now, a super common way to write these acceptance tests is using something called the given, when, then model. It's a really simple, human-readable format. For example, given a user is logged in, when they add an item to their cart, then the cart total should update correctly. See? Super clear. This structure is absolutely perfect for testing what we call the happy path, which is just the most common, successful journey a user takes to get something done. Okay, moving on. Let's head down to the bottom right of our map. This is Quadrant 2. So these tests are technology-facing, and they also support programming. These are really the tests written by developers for developers. This is where you'll find things like unit tests, which check tiny, isolated pieces of code. Think of them like individual Lego bricks. And you'll also find component tests, which make sure that several of those Lego bricks fit together correctly. The main goal here is just to make sure the code is technically sound and robust.
Now, a really crucial technique here in Quadrant 2 is the idea of test doubles.
And the best way to think about this is like a stunt double in a movie. See, to test one specific piece of code all by itself, you often have to replace the things it depends on, like a giant complex database or some external web service. You swap them out with a simpler, predictable stand-in. That's a test double. And they come in a few different flavors, like stubs that just give you pre-canned answers, or mocks that have very specific expectations about how they're supposed to be used.
Okay, now let's cross over to the left side of our map. This whole side is dedicated to critiquing the project. Let's look at Quadrant 3, in the top left. These tests are business-facing, but their job is to critique the project. This is often where you find manual activities, like exploratory testing, usability studies, and showing the software to real users. And notice the really subtle but profound shift in the question we're asking. We're not just asking, are we building the product right anymore? Now we're asking a much more fundamental question. Are we building the right product? Is this software actually valuable? Is it usable? Do people even want it?
And that brings us to our final stop, Quadrant 4 in the bottom left. These tests are technology-facing, and they also critique the project. This is where we look at all the system's non-functional characteristics. You might hear these called the abilities, like reliability, scalability, and so on. We're asking questions like, how does it perform when a ton of people are using it at once? Is it secure? Is it reliable over time? These tests really critique the deep-down architecture and technical guts of the system to make sure it's not just functional, but also robust, secure, and scalable.
So when you put it all together, you can see that a truly comprehensive testing strategy has to address all 4 of these quadrants. But how do we apply this nice, neat model to the messy reality of actually building software? Well, in this next section, we're going to look at exactly how to use this map to navigate a few common, real-world situations.
We're going to look at 3 different situations that you will almost certainly run into in your career. First, starting a brand new project from scratch, what they call a greenfield project. Second, joining a project that's already up and running. And third, the big one, tackling a legacy system that has very few or maybe even 0 existing tests.
First up, new projects. This is really the dream scenario, right? You have the perfect opportunity to set up strong quality practices from the very start. The strategy is simple. Start writing automated acceptance tests, our Quadrant 1 tests, from day 1. Doing this immediately starts building that executable specification we talked about, and it guarantees that quality is a core part of the process, not just some afterthought you tack on at the end.
Okay, but what if you join a project that's already in motion? Well, you can't test everything at once. There's an old saying, you can't boil the ocean. You have to be strategic. The absolute best approach is to figure out what the most critical, highest value parts of the business are. Then you focus all your effort on automating the happy path tests for just those functions. This gives you a huge return on your investment right away by creating what's called a regression safety net. It's basically a set of tests that make sure any new changes don't accidentally break the most important stuff.
And finally, legacy systems. These are often jokingly but very accurately defined as systems without tests. The guiding rule here is simple and, most importantly, safe. Just test the code that you change. You can start by building a small set of really broad smoke tests. These are just quick, high-level checks to make sure the absolute core parts of the system are still working. Then, anytime you fix a bug or add a new feature, you add more focused tests for that specific area. You're slowly and safely bringing the system under that safety net of automation. All right, so as we start to wrap this up, let's just summarize the core philosophy behind this whole approach. It really is all about developing a brand new mindset about what testing is for. Because the results of a strategy like this are really profound. I mean, a good testing approach does so much more than just find bugs. It builds confidence for the entire team. It slashes long-term maintenance and support costs. It actually encourages better, cleaner code design. And like we said, it gives you the most valuable kind of documentation you can have, one that literally proves it's correct every time you run it.
So if you remember just one thing from all of this, let it be this. Testing is not a single activity. It's not a final phase. It is the practice of creating fast, effective feedback loops. And these loops, they inform and drive everything we do, from the tiniest bit of code design all the way up to the biggest product decisions. It creates this amazing cycle of continuous improvement.
And that leaves us with one final question for you to think about. What is the real goal of your testing efforts? Is it just a reactive process, finding bugs after they've already been made? Or is it a proactive process of building confidence every single step of the way that you are delivering the right value to your users and that you're delivering it correctly? Because the way you answer that question, well, that's what's going to define your entire approach to quality.